We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello student, I am Bhavesh Patel. In this session we are going to discuss about the EMI, electromagnetic interference, and its sources and mitigation techniques. Let us start with introduction of EMI. Introduction of EMI. Any conductor carrying electrical current has an associate with magnetic field. A magnetic field can induce voltage or current to a medium which is linked. Changing any one field will affect the other, and the effect of this electromagnetism over any sensitive devices is known as electromagnetic interference, EMI. Any devices that has electronic circuitry can be susceptible to EMI. Many electronic devices fail to work properly in the presence of strong radio frequency field. In many electrical apparatus, the relationship between electrical current and magnetic field is used. For example, utilization of electromagnetic principle are motor, generator, transformer, induction heating furnace, relays, and electromagnet, etc. But in nowadays, many power electronics and telecommunication sector develop, so the EMI becoming major issue for the industrial and power system also. The sources may be any object, artificial or natural, that carries a rapidly changing electrical current. Okay, it is the EMI. Then next, sources of EMI. EMI source. The 2 types of EMI source, natural EMI sources and man-made EMI sources. The first, natural EMI source. Sources of electromagnetic noise associate with natural phenomena including atmospheric charge discharge phenomena like lightning and precipitation static. The lightning means whenever air between cloud and earth will breaks, there will be a flash of lightning occurs. The lightning is the one type of discharging of a high global capacitor between charged cloud and ground. So this is the source of EMI. Then precipitation static. Precipitation static means static produced in airborne radio equipment by the striking of rain, snow, hail, dust particle or other particles in the atmospheric, on the antenna and surfaces of the airplane. Okay. Then extraterrestrial source, okay, including radiation from the sun, star, galaxies and other cosmic sources. Okay. They are resulted from thermal ionization due to the movement of ion of very high temperature and thermal noise produced due to the heat radiation from them. They also emit the broadband and narrowband radiation. Okay. So these are the sources of natural sources of EMI. Second, man-made EMI sources. Sources of electromagnetic noise associate with man-made electrical devices like power lines, auto ignition, fluorescent light and so on. Because of electrical and electronic devices that are used in our day-to-day life. Okay? This is the major source of EMI. Then we including AC unit, alternator, blower fan, engine, inverters, radar, wiring, etc. Then next, mitigation of EMI. The first, shielding for radiated emission. The radiated emission means signal energy data reaches susceptible equipment via broadcast or by capacitive or inductive coupling with air and gas medium. Okay, it is generally expressed in volt per meter. The shielding is, what is the shielding? Shielding is the metal enclosure from frame. Okay, metal enclosure or frame provided to avoid the noise from entering the susceptible equipment, and they may be applied at the source if source is known. Okay, if source is known, then they be applied at the source. Okay, and also apply at the susceptible devices. Okay, for control of radiation emission, shielding is applied at source and affected device. Shielding, the victim or affected device need continuous metal covering around the device which allow the EMI close to the seal but not inside the seal. When EMI strike the seal, eddy current is injected into the seal or in a direction that result in field cancellation in the vicinity of the seal. The material generally use high conductivity metals such as copper, aluminium are effective sealing material, and this material is very useful for high frequency EMI application. Shielding depends on the thickness which has larger strand matching to the EMI frequency. This is the first EMI mitigation by shielding. Second, filter for conducted emission. The conducted emission means EMI propagated via conducting medium or common connection. Okay, the EMI entering via conducting medium and common connection, generally measured in volt or microvolt. The filter are normally employed to the source. Okay, source element of noise, so they don't propagate the other load. Okay, noise means it is the unwanted electrical signal. Okay, so to filter prevent the noise and not entering the any devices. The filter may also be applied to the load end. Okay, and protect the separate piece of equipment. The filters are provided a certain degree of attenuation of conducted emission. Okay. Attenuation means it is the ratio by which unwanted noise or signal is reduced in amplitude. Okay. The filter provides a certain degree of attenuation of conducted emission. Okay. Filter do not completely remove the noise or attenuation but reduce the level of might be tolerated by sensitive devices. Generally filter use, it is the passive component like resistor, inductor and capacitor, and filter the particular frequency band. Okay. To filter other, okay, for example to filter other band, then multi-band filter can be employed or multiple filters are necessary. Okay. Each type or model of filter, manufacturer filter provide frequency versus attenuation characteristic. Okay. So for any purchase any filter, it is or any mounted filter, it is the most important. We know the frequency versus attenuation characteristic. Okay. And before applying the filters, it is essentially to find out the choice of offering frequencies. Okay. It is also necessary. Sometimes filter may be applied in cascade to derive higher attenuation. Okay. The filter may be applied in a cascade manner for high degree of attenuation removal. For example, two filters, each providing 40 dB, 100:10 attenuation may be applied, okay, in series. Okay. Then derive attenuation of 80 dB, 10,000:1. Okay, if we are connecting 240 dB filter, then we remove the 80. Okay, 40 plus 40 connected in series, we remove 80 dB attenuation remove. Then next, device location to minimize interface. Okay. Location is most important. Okay. The electrical and magnetic field diminish as the square of the distance between source and victim. So electrical and magnetic field vanish as the distance of the signal and wire increase. Okay. Attenuation can be reduced to a great extent if the victim or affected device is removed away from the EMI source and by proper orientation. Okay. An above idea is useful only for distance between source and victim is small. Okay. Above discussion is most important or most effective when distance is small. Okay. Distance between source and devices is small, and not effective if source is located far from the victim. Okay. If source and victim devices are higher distance, at the time this idea is not proper. Okay. It is for small distance. Okay. The device location for minimizing the interference, the location is most important. Okay. Then next, soft switching. Okay. Generally, soft switching with IGBT, MOSFET and diode as a switching component is able to reduce the EMI with low di by dt and dV by dt. With low resonance produced in switching, EMI can be reduced at high level. The soft switching also important. Then grounding also important. Appropriate grounding is the most common method to mitigate the EMI in device. Okay. Then enclosure. For EMI mitigation, enclosure should be made of a magnetic steel. Okay. Separate enclosure for incoming and outgoing power and mitigate EMI more efficiently. Okay. The separate enclosure and material also important. EMI gasket can be used for eliminating noise. Okay. There are the reduction or mitigation technique. The next, conclusion. The conclusion from the above survey or discussion, we can say that electromagnetic field are everywhere, and some devices like TV, radios, etc. would not work without this field. And this energy is useful in day-to-day lives. But susceptible devices managed with seal, filter and isolation techniques is necessary. Okay. Thank you.